Now for this problem, we're asked to find the partial derivatives of this function for the partial derivatives for x, y, and z. So we'll go ahead and do the easy half first. When you take the partial derivative of the square root there, we know all of our denominators are going to be 2 square root of x, y plus 2xz plus 3yz. Now we actually have to do the numerator then, taking the partial derivative with respect to x. The third term drops off, so we just wind up with y plus 2z plus 2z. And then with respect to y, we've got the middle term that drops out, and our numerator becomes x plus 3z. And our denominator is the same thing again, x, y plus 2xz plus 3yz. And then for partial derivative with respect to z, now we just take the last two terms. It becomes 2x plus 3y. And same denominator, x. Okay, so there we have the solution to the A part of the problem. Now for the B part, it tells us to let x equal yv, y equals u plus 2v, and z equals negative v squared, and then asks us to compute the partial derivative of f with respect to u when u equals 2 and v equals negative 1. Okay, so with this now we've got the new assignment here. We're going to pick up x equals u v, y equals u plus 2v, z equals negative v squared. And now we have these variables that actually get an assignment. So we're going to go ahead and start plugging in numbers here to simplify and start getting rid of variables as we go, so we don't have to keep carrying all these variables around. So now, plugging these in, we can make assignments for x, y, and z. So x now becomes u times v. So x now equals negative 2. Y is u plus 2v. So then that works out to 0. And then we have z, which is equal to negative v squared. So that then becomes negative 1 squared, and then negative of that also is negative 1. So what do we do now? Well, let's start by defining, because it's particularly asking for our partial derivative of df du. So how do we come up with what's required? Well, let's go ahead and do our tree. We're starting up here with a particular function, and we're going first through the 3 variables, which are x, y, and z. And now each of those splits off into 2, uv, uv, and uv. So what we're solving for here, though, is just with respect to u. We don't have to worry about the v's. So we can calculate which partial derivatives we need to construct this. We have df, first going through x to get to du, df, dx, dx, du, plus df, dy, dy, du, df, dz, dz, du. So now we need to start plugging in what these individual units are. Well, let's come up here and solve for the first of each of those, and we'll go ahead and plug in the numbers so that we can get some answers here. Well, all our new denominators are going to be the same. So then solving for this, plugging in our y and our z being -2, then the y drops out, -2, and then for the denominator, we plug in the numbers here. Well, y is 0, so both the first and last terms drop out. We just now have square root of 2 times xz, which is square root now of 2 times 2, which is 4. So now all our denominators are going to be equal to 2. So that's going to, or equal to 4, 2 times 2. So now this is going to simplify to -1/2. Now with df dy, we've got x equal to -2, z equals -1. So we've got -2 minus 3 gives us -5 over 4. And then finally, plugging in, we just have x, y is 0. This now gives us -4 over 4, which equals -1. So that's giving us our 3 values for the first ones. But we need to take now the partial derivatives of x with respect to u. I'll just plug these in as we go. So the df dx, we have -1/2. Now, our dx du, taking the partial derivative of this will give us, well, with respect to u, that drops out, we just have v. And v is equal to -1 plus, now we have df dy, which is -5/4. And then dy du, okay, well, that's a constant, so that drops out. We just have u, so that's 1. And then the dz du, there's no u in it, so that that becomes 0 for its partial derivative, so we know that will just drop out. So now, solving for this, this is going to be +1/2. I'll go ahead and put it 2/4, since we've got that, minus 5/4, which equals -3/4. So that then is our solution to B.